I'm going to begin from the equation of a progressive wave. Equation of a progressive wave. So now I'm just going to consider a particle. Let me say this is y displacement. Consider a particle at O. Particle at what? O. Which is vibrating at O. So when it is vibrating, there's what we call simple harmonic motion, whereby a particle vibrates to and fro. Okay? So to and fro what? Motion. Just like vibrating up and down. With the frequency. Frequency is the number of cycles made in 1 second. Meaning the number of times the body vibrates in 1 second. That's what we call frequency. And as it vibrates, it has angular velocity. It has speed, angular velocity, okay? So we shall now say that now, if the particle is vibrating here, and a disturbance is produced, let's say this is a disturbance. Like that. And then we say that we consider a particle at point P, which has moved a distance x from there. And then at the particle P here, the phase difference, so the phase angle which it has met is phi. And then we say that for one complete cycle where we have 2 pi, we know that when a particle makes a complete cycle, then the distance is what? Is lambda. So we shall now say that consider a particle at O vibrates in simple harmonic motion. Vibrates with simple what? With the simple harmonic motion. The to and fro particle. Whose displacement? Whose y displacement is given by y is equal to a sine omega t. Where a is amplitude, okay, and then omega is angular velocity. Angular velocity. Okay? So we substitute, then from there we shall now say that a particle, consider a particle, okay, at P, which has moved at P, a distance x from where? From, so the particle at P, this means that particle at P lags behind what? Lags behind the particle at O by phase difference. Phase difference of omega t minus phi. So now it will be now particle at P will have y is equal to a sine of omega t minus phi. Where phi is the phase angle. The phase angle, which depends on the distance covered. The distance x covered by the particle. The distance x covered by what? By the particle. So we shall now say that phi is proportional to x. Let me say for one cycle, the phase angle is 2 pi, Now the distance for the complete cycle, the distance is lambda. So meaning that the angle which is covered in, or the phase angle covered, the phase angle which is subtended by a particle that has made one complete cycle. A complete cycle is like making a circumference of a circle, which is 360, and in radians is 2 what? 2 pi. So the angle will depend on the distance covered, which distance is lambda. So is it lambda? So if I have to explain this one, how am I going to explain? Let's see, grab this one off because we don't need it. We are considering a particle, or we are considering a wave traveling from left to right, isn't it? From left to what? To right. So it means we are saying that now, from left to right, that's the positive direction, which can be like clockwise if we are to take it in terms of what is circular motion. That is clockwise. So if you have, let's say, this is a circle. This is, then we say, a particle here, vibrating to and fro here, to and fro, okay? The angle which to cover, to and what? To and fro. So this is omega t, this is also omega what? Omega t, okay? To and what? To and fro. About the equilibrium position, so this is equilibrium what? Equilibrium position, okay? To and fro. So since it's vibrating in simple harmonic motion, the angle, okay, will be omega what? T. The angle covered, up and down. Omega what? Omega t. Now let's see, this is a particle now. Let's say this is a particle at that position. Now, we have the particle at position P. The particle at position what? At position P, which has moved the distance x. What? So this is omega t here. We're saying that it lags behind. It's like here. This is a particle at the position what? P. It lags what? Behind. This particle, okay? It lags behind this particle. So since the lag is behind this particle, because it's supposed to be moving like this, since the lag is behind this particle, then the angle from the equilibrium position, this angle is what? Is phi. That angle is what? Is phi. So what will be this angle here? What will be this angle? It will be, so we can say that if this one is to go back, okay, then we can say that the change here will be omega t minus what? Minus phi. Okay, we can take it like that, or is another case we can take it if the particle is here. Let me say if the particle is here. Okay, we can take that one. So we're saying that the angle between the two, we shall now say that it is, so here in other words, we would say that we have two particles, okay, which are oscillating. So a particle which makes a complete cycle, that is the circumference of the circle, the distance is wavelength. Now we look at the particle at the what? At the equilibrium position. At the equilibrium position, the particle is vibrating to and fro. That is harmonic motion, up and down. Okay? So the angle, the first angle which that particle subtends is what? Is omega t. Now, since this is a sinusoidal whereby the displacement of that particle varies with time. Varies sinusoidally with time. So it is a sinusoidal. That's why I'm using sine. Y equals a sine omega t, where omega is the phase angle that is being subtended there. So when you consider a particle which has moved this side from left to right, that particle lags behind. Since the lag is behind, there is a change in phase what? Phase angles. And the change in phase angle will be omega t minus the other angle which the particle has what? Has made. Okay? That is omega t minus phi. But that phi depends on the distance, the position of the particle. Okay? Does not mean that all the particles which have moved have the same phase what? Angles. No, they don't have the same phase what? Angles. They'll have the same phase angles if they are in the phase. You understand? But if they are not in the phase, they will not have the same phase angle. So the phase difference will be omega t minus what? Minus that angle. So that angle depends on the position or the x, the distance which the particle has moved from the source. Okay? From where? From the source. So, and we are also comparing it with the particle which has moved a complete cycle. So this is equation 1. What is equation 1? This is equation 1. Then this is equation 2. 5 is equation what? This is equation 2. This is equation 3. So equation 3 divided by 2. 3 divided by 2. We shall have 2 pi over 5 2 pi over 5, giving us 2 pi over 5, giving us lambda over x. So that means we shall have 5 as 2 pi of lambda x divided by what? Divided by lambda. So equation 1 becomes y is equal to a sin omega t minus 2 pi x over lambda. But omega is equal to 2 pi what? F. So we shall have y giving us a sin 2 pi f t minus 2 pi x over lambda. Factorize out 2 pi, so y will become a sin 2 pi into, we shall have ft minus x over lambda. Very important equation. Very important what? Equation. Very important equation. We say for the wave, so this implies this case, this is the case for the wave traveling from where? From left to right. From left to right, or in positive x direction. Then we could say for the wave traveling from right to left, from right to left, or negative what? X direction is given by, so we shall say minus phi, because in negative x direction, so we take it will be like it, we will say y is equal to a sin omega t minus phi, like this. So we add it, so it will become y is equal to a sin omega t plus phi, or y is equal to a sin 2 pi into ft minus x over lambda. Okay, then we look at the examples. Number 1, we say that displacement of the wave is given by y is equal to it is a sin 2 pi into t over 0.5 minus x over 0.2. It has find the speed of the wave. Find what? The speed of the what? The waves. So what do we do? We shall come here and say, they have given us the equation as y is equal to a sin 2 pi into t over 0.5 minus x over 0.2 meters. So we compare with the y is equal to a sin omega t minus phi, but you already know omega and you already know phi. So it is 2 pi ft minus x over lambda like that. Compare. So I'm going to compare the coefficients of t. So 1 over 0.5 is equal to f. Okay? So our f will become 2 has. Next, 1 over 0.2 is equal to 1 over lambda. So lambda will become 0.2 meters. So we shall say that using v is equal to f times what? Lambda. This will now become f, our frequency is 2 times 0.2, which is 0.4 meters per what? Per second. That is example number what? Number 1. Then example number 2, we shall say a sound wave propagating in x direction is given by the displacement of sound wave propagating in x direction is given by y is equal to 0.4 sine 0.4 sine of 100 sine of 10 into 200 t, sine of 10 into 200 t, then minus x over 100 meters, x over 100 meters, like that. Then the question goes and says, find part 1 amplitude, part 2 frequency, part 3 wavelength, then part 4 speed of the wave. Speed of the what? Speed of the wave. So our general equation is given by y is equal to, the equation is given is 0.4 sine of 10 into 200 t minus x over 100 meters. So the general equation says y is equal to a sine of 2 pi into ft minus x over lambda. So when you compare part 1, we shall get our amplitude as 0.4 meters, this and this. Then part 2, we shall have our part 2. Part 2, we compare frequency coefficient here. This is 2 pi. The bracket is here, so where is t? That's what the frequency is. So our frequency is 200. Our frequency is 200 what has. Then part 3. Part 3, compare this and this. That means that 1 over 100 is equal to 1 over lambda. So lambda is equal to 100 meters. Then after that, part 4, v is equal to f times lambda, which will become f. That's a 200 times 100, which gives us 320 what? Meters per second. That is how these questions can be treated. Then can move on. We do the third one. We do the third one. The third one says a progressive wave is represented by, that's number 3. Is represented by y is equal to 0.1 sine 0.1 sine 100 pi minus 10 pi x over 9. This would be in meters. Then the question goes and says find part 1 amplitude, part 2 frequency, part 3 wavelength, part 4 speed of wave, part 5 speed of wave particle, part 6 phase difference between phase difference between a point 0.245 meters from O and 1.10 from O. So come here, we got the solution. How do we handle this? So we shall now say the equation given is y equals 0.1 sine of 100 pi minus 10 pi over 9x. So from here, the general equation is y equals a sine. Now the 2 pi is the pi is inside, okay? So you use a is equal to sine omega t minus phi. Then you substitute omega and phi. So to sine 2 that's 2 pi ft minus 2 pi over lambda x. So part 1, what's the amplitude? Part 1 amplitude is 0.1 millimeters. Then part 2, what is our frequency? Compare 2 pi f. 2 pi f will give us 100 pi. So f will become 50 Hertz. Then the next question is wavelength. Compare 10 pi over 9 should give us 2 pi over lambda. So this will cancel. So our lambda will become 1.8 millimeters. We continue. The speed of the wave, part 4, v is equal to f lambda, which will now become 50 times 1.8 times negative 3 in meters, which becomes, this is 9, this is 90, that's 900, I think. This is 90, this is 90 times negative 3, which is 0. I think 0.9. 0.09, okay, meters per second. Then part 6, part 5 speed of particle. We shall use here as you move on. There is what you call simple harmonic motion. That's when you should look at how to get the speed of the particle, the particle that is in simple harmonic motion, that is vibrating. Therefore, we shall use this equation that v is equal to omega a, where a is amplitude, okay? Amplitude. So what is our omega? How do we get our omega? Is 2 pi f. So v will become 2 pi f times a, but then our 2 pi f is same as 100, not so? So it's same as 100 pi. So this is 100 pi times amplitude, which is 0.1 times 10 to the negative 3. Okay, so this is this one here, that's 10. So it becomes divided by 1,000 in other words. So 2 zeros will cancel. So we shall have 0.01 times 3.14, which the answer becomes 0.0314 meters per second. The phase difference. The phase difference between the particles. So that means the phase difference between the particles, we are going to get the phase difference, change in phase, will be equal to phi 2 minus phi 1, which is same as 2 pi over lambda x2 minus 2 pi over lambda x1, which is 2 pi over lambda into x2 minus x1. So we can substitute. We shall now have 2 pi divided by lambda. So remember our lambda is what? Our lambda will get 1.8. 1.8 multiplied by negative 3 into this is 1.10 minus 0.245. So this is 2 pi, 2 times 3.14 times, when you subtract you get 0.855 divided by 1.8 times 3. So the answer we get will be in radians. Radians, okay? Will be in radians because we have used the pi as radians. Okay, we have used the pi as radians. This is first angle. We cannot say it is in degrees. It should be in radians because we use the pi as 3.14. And the pi 3.14, that is radians. So the answer we get will be in what? In radians. After using the what? The calculator. So then after that, you can put exercises. Let me type here. Exercises. You can say exercise number 1. A displacement y is equal to y is equal to 0.5 sine of 0.5 sine of pi into 200t minus 200t minus 20x over 20x divided by 17. Then I say find wavelength and speed of the wave. Okay, find, this is meters, the speed of wave. That's one. Number two, the displacement is given by, the displacement of the wave is given by y. Let me see. Y equals 2 sine. Y equals 2 sine 2 pi into 2 pi into t over 0.1 minus t over 0.1 minus x over 0.2. Find amplitude and speed of the wave. Find amplitude, speed of the wave, and its period. And it's what? Period. Like that. Then we shall go ahead and we look at what they call we look at stationary what? Stationary waves. We said these are waves formed when waves formed when two progressive waves of equal amplitude and frequency, but traveling in the opposite direction at the same speed. Superimpose. Okay. Then from there, we shall look at conditions for stationary waves to be formed. Conditions for the formation of stationary waves. The first one, we shall say the waves must be moving in opposite direction. Waves must be moving in the what? Opposite direction. Next, we shall say they must be moving in the opposite direction. Next, the waves must have the same speed, same frequency, and waves must have the same speed, amplitude, and frequency. The same speed, amplitude, and frequency. Then we shall go to condition so the formation of stationary waves. You say stationary waves are formed when two waves of equal frequency, amplitude, traveling at the same speed in opposite direction are superposed, resulting in formation of antinode and nodes. Now, when we talk of antinode, at antinodes wave meet in phase and amplitude is maximum, and we are saying that when they meet like this, so this one is moving like this, then it's reflected back, it comes back like this. So this one is called node, here is antinode, here is node, here is antinode, here is antinode. So at the antinode, waves meet in phase, resulting in maximum displacement. Okay? Here the waves meet completely out of phase, resulting into zero displacement. Or resulting into the maximum, here maximum amplitude, here minimum amplitude. So you make sure to write the fields down. Then we go to superposition principle. Superpositioning principle. How do we state superposition principle? We go to superpositioning principle. So we shall say that states that for two waves traveling, traveling in the same region, for the two waves traveling in the same region, the total displacement at any point displacement at any point, okay? The total displacement at any point is equal to the vector sum. Is equal to the vector sum of displacement at that point. Of their displacement at that point. Of their displacement is equal to the vector sum of their displacement at that point when they overlap. When they overlap. overlap. Then from there we consider a wave traveling from left to right. Consider a wave traveling from left to right, from left to right, okay? Y1 is equal to A sin omega t minus phi. Then we said this very wave is going to be reflected, okay? This wave is going to be what? Reflected. So when it is reflected, what happens? When the wave is reflected, maybe from a barrier, when the wave is reflected, we shall have y2 as A sin omega t, now plus what? Plus phi. Okay? Plus phi. So we shall now, but therefore, according to superposition principle, says that the total displacement at any point is equal to the vector sum of their displacement at that point. So that means y will become y1 plus y1. So y will become A, factorize out to A, sin omega t minus phi plus sin omega t plus what? Phi. So what do we do? Open brackets. So y will now become A, this is sin omega t cos of phi, then minus cos omega t sin phi. Then plus, here we shall have sin omega t cos of phi, okay? Then plus, okay, cos omega t sin of what? Phi. So from there we have this cos omega t and this one will cancel. So when they cancel, we shall say y is equal to A into this plus that, shall have 2 start with cos phi sin omega t. So y becomes what? 2A cos phi sin omega t. But then remember, this displacement, okay, depends on time. Depends on what? Time. Varies with time. It does not depend on x, the displacement. So we shall now say that since it depends on time, then this is a constant. Since it's a constant, we shall replace it with this A sin omega. This is the equation of stationary standing wave. Of stationary what? Wave. With amplitude given by amplitude given by amplitude is A, which is same as 2A cos phi, or A is same as 2A cos of 2 pi over lambda times x. 2 pi over lambda times x. So that is the equation of stationary wave. And therefore, I'll ask you a question. I'll put here assignment. Okay, I can say differences between stationary and progressive what? Progressive waves. What are the differences? Let me draw a table. Let me say, here it says stationary. Then in this side I put what? Stationary. Here I put progressive. Number one, under stationary wave energy is not transferred. Is not transferred. Is not transferred, but confined within the system. But confine it to a particular section. But confine it to a particular section. Then you will say wave energy. Energy is what? Is transferred from one point to another. Another. That's one. Number two, we talk of the amplitude. So here, amplitude of particles in the medium varies with the amplitude. We see that amplitude of particles varies with the position, of particles along the wave, wave. You will see that the amplitude, it is A to A cos what? Cos 2 pi x over lambda. So it varies with x. Then what about under the other side? My chalk. Then the other side said that all particles vibrate with the same amplitude. All particles in the medium vibrate with the same amplitude. With the same amplitude. With the same amplitude. Then the third one, only particles in integral multiple of wavelength and phase. Only particles in integral multiple of wavelength are in phase. We shall see that on how the integral multiple comes in. We shall see. And then we shall say that all particles between successive crests, here we shall say, all particles between successive crests and troughs are in phase like that. So here I can also say stationary wave has crests. So stationary wave has nodes and antinodes. This one has crests and troughs. Then we can also that the wavelength. Here the distance between two successive nodes or crests is wavelength. Here the distance between two successive nodes and antinodes in the phase. Here the distance between two successive crests and troughs are in phase. Or we can say that the distance between the two particles in phase, the distance between two successive particles in phase is lambda over 2. Here, the distance between two successive particles in phase is lambda. Okay? Is lambda. So I think with that, we can first pause there. First pause on that.